It's raining glass sideways at 9 kilometers per hour in massive storms that can last for days. And if you were to get caught in one, your body would be shredded to atoms. This is what it's like on the extremely hostile planet HD 189733b. And this is our channel. This exoplanet is located in the constellation of Vulpecula, about 64 light-years from Earth. It was discovered in 2005 and is slightly larger than Jupiter. But there are two major differences between HD 189733b and our gas giant. First, unlike Jupiter, which orbits a relatively small and weak star, HD 189733b orbits a blue giant star almost 8 times larger than our Sun. This means that despite being only 64 light-years away, the planet receives nearly 10 times more energy from its star than we do. Second, HD 189733b is incredibly close to its star, making a full orbit every 2.2 days. In comparison, Mercury, the planet in our solar system that orbits closest to the Sun, takes 88 days to make one revolution around our star. Such proximity to a hot star means that HD 189733b experiences scorching temperatures of over 1000 degrees Celsius. These two factors make the conditions on this planet absolutely hellish and completely uninhabitable. Despite all this, scientists managed to learn quite a lot about it, including that it has an ocean of molten glass. But how did they find out? Well, thanks to modern technology and powerful telescopes such as Hubble or the James Webb Space Telescope, we can study not only visible light but also other types of radiation from distant stars and planets. By analyzing the light that passes through faraway planets' atmospheres, we can determine what part of the light spectrum gets absorbed by certain chemicals, allowing us to figure out what kind of atmosphere they have. Scientists figured out that HD 189733b has an atmosphere, but it's primarily composed of hydrogen and helium, much like Jupiter. However, the atmosphere of this planet also contains significant amounts of vaporized silicates, which are minerals that contain silicon and oxygen, like quartz. For example, when these silicates reach a critical temperature, which on this planet is just about 400 degrees Celsius, they turn into vapor. And since HD 189733b is almost 8 times hotter than that, the surface of the planet is covered with a thick layer of glass in a liquid state. But how do we know that it rains on this planet? Well, as it turns out, scientists once again had to analyze the planet's atmosphere to find out, this time using the method called transit spectroscopy. As a planet passes in front of its star, some of the starlight filters through the planet's atmosphere and we can measure how much of it does. If there are clouds in the atmosphere, then the amount of light will be slightly different because the clouds will scatter and reflect light in different ways. Analysis of the data collected showed that on HD 189733b, there are no clouds in the upper layers of the atmosphere. But lower down, scientists found silicate clouds. It was also revealed that these clouds are humongous and reach millions of tons in weight. So when they get saturated with water, which is also present on the planet in a gaseous state, the glass in the upper layers of the atmosphere simply CAA and hold all that moisture anymore, and it starts raining. In addition to rain, strong winds have also been found on this planet. They reach speeds of 18,000 kilometers per hour. That's why the rain falls sideways. Imagine being on a flat surface, looking up at the sky, and suddenly, hundreds of millions of tons of molten glass begin to fall from above, falling sideways at 18,000 kilometers per hour. You would never have time to react. You would instantly be hit by a glass shard and your body would be shattered into atoms. What's even scarier is that these rains and winds can rage for weeks. A year on HD 189733b is just 11 days long. And during this short period of time, it can rain glass for as long as 3 days straight. To make it even more terrifying, these storms occur not only on the surface, but also in the atmosphere of the planet. And if you manage to survive the rain, the thing is, the atmosphere of HD 189733b is divided into several layers and each of them differs in density, pressure and temperature. The lower layer of the atmosphere is called the troposphere. It's here where the weather happens. The higher you go, the fewer molecules of any substance there are in the air. So the higher you go in the troposphere of HD 189733b, the colder it gets. The lowest temperatures on the planet can be found at an altitude of about 180 kilometers. Here, the temperature drops to minus 136 degrees Celsius. But don't think that this is a good place to hide from the glass rain. At these low temperatures, all the glass simply freezes, and falling shards hitting your body would feel like being stabbed with millions of knives. And even if you somehow manage to stay alive after the rain stops, you'll still die. Just a little higher, there's a stratosphere, where the temperature begins to rise again, reaching plus 250 degrees Celsius. And even though the glass won't freeze here and cause you any additional damage, you'll still die from the intense ultraviolet radiation that's present in these parts. Higher up is the mesosphere, where the atmosphere gradually becomes thinner and the air pressure drops. Finally, beyond the mesosphere lies the thermosphere. Here, the atmosphere practically merges with outer space. Also, the vacuum of space has a tremendous effect on this area of the planet. All of these factors make the thermosphere the most dangerous part of the atmosphere of HD 189,733b. You'll be torn to shreds by the low air pressure and die instantly. On the other hand, if the glass doesn't reach you and you manage to survive the rain, you'll burn to death in the atmosphere. The temperature here reaches 1,800 degrees Celsius. No known material on Earth can withstand such high temperatures and low air pressure. But maybe there's somewhere to hide from the glass rain and storms on this planet. Let's look at it this way. The average density of HD 189,733b is about 0.1 grams per cubic centimeter. For comparison, the density of water is 1 gram per cubic centimeter. Therefore, the gravitational pull of HD 189,733b is about 6 times weaker than that of Earth. It means that an object weighing 100 grams on Earth would weigh only 16 grams on this planet. It means that the glass shards falling on this planet would fall very slowly, perhaps even slower than raindrops on Earth. Theoretically, if you found shelter under a rock big enough to protect you from the rain, you could survive. Of course, provided you don't burn to death in the atmosphere or freeze in the lower layers of the atmosphere. Such a rock exists on this planet, although it's unlikely that you'd ever find it. And that's because HD 189,733b is covered in a thick layer of glass. In general, it resembles a gigantic ball made of molten glass. The thickness of this ball is about 150 kilometers. So finding a rock underneath would be nearly impossible. Additionally, the crust of this planet is in constant motion due to volcanic activity. Molten glass is constantly seeping out of the cracks in the crust. And let's not forget about the insane storms that rage on the planet. The wind can easily blow away any shelters you might try to hide in. It's like trying to survive a hurricane on Earth, except here, the glass rain makes everything much worse. In conclusion, even if you put on a special spacesuit capable of withstanding both high temperatures and low pressure, you'd still die on HD 189,733b. The fact is that the swings in air pressure would cause your blood to boil and then freeze in your veins. So let's be glad that there are no planets like HD 189,733b in our solar system, at least none that we know of. And if there are, let's hope that they're so far away that we can't even see them. Now watch, what if a black hole appeared on the sun? Or check out this video instead. It's pretty interesting.